I'm solving a full grade 12 or AP calculus exam that I found in one of my old notebooks. Every question is straight from that test. We're covering all the key topics. And some tricky derivatives at the end. Kind of like you're cramming the night before. Timestamps are also in the description, so feel free to skip to whatever you want to study. Good luck cramming. This exact type of question shows up on your calculus exams all the time. We're finding where a function is concave up and concave down using the second derivative. Let's break it down step by step. So let's find the intervals on which f of x is concave up and down. We can do this in a few easy steps. Step 1 is to just find the first derivative. So f prime of x is equal to 15 x to the fourth minus 15 x squared. Next, we find the second derivative. You do this by just taking the derivative again. So basically the derivative of the derivative. If we do the power rule again, we get 60x cubed minus 30x. The second derivative gives us information about concavity. But to actually get this information, we need to expose the roots and solve for them. So you can find the roots we're looking for by setting the second derivative equal to 0 and factoring. So 60x cubed minus 30x is equal to 0. I'm going to factor out a 30x. That gives us 30x. And then in brackets, we have 2x squared minus 1. And that's all equal to 0. Let's get the roots now. So we have 30x here is equal to 0, which gives us x is equal to 0. And here we have 2x squared minus 1 is equal to 0. This gives us x is equal to plus or minus 1 over root 2. So all we need for the next part of the problem is the roots and the second derivative. Okay, so now that we have all of our information to solve the problem, f double prime and its roots, we can use a number line to figure out what's going on the left and right side of each root. Also, I've approximated 1 over root 2 as plus or minus 0.7. I find it's just a little bit easier to read on the number line. So first things first, let's place our roots on the number line. We have 0 here, we have negative 0.7 on this side, and then positive 0.7 on this side. So the first test number would be here, then we have another one between the roots, right, on the left and right side of each root. And the last one is on the far right side. So what's on the left side of negative 0.7 on the number line, or in other words, what's more negative than negative 0.7? Well, that's negative 1. And then we apply this same logic to the rest of the problem. So what's between negative 0.7 and 0? Negative 0.5. And then we can fill in the rest. Positive 0.5 and positive 1. So now let's input our test numbers into f double prime. On this interval, we're getting f double prime of negative 1. Then we need f double prime of negative 0.5. Then f double prime of positive 0.5 and positive 1. Computing this, I get a negative for f double prime of negative 1. Then I get a positive for this one, negative for this one, and a positive for this one. So the second derivative tells us information about concavity. When it's negative, in the first case here, it's concave down. When the second derivative is positive, it's concave up. And now we can fill in the rest. But the question asked at what interval? So the interval from left all the way to negative 0.7 is negative infinity to negative 0.7. Then we have an interval between negative 0.7 and 0 here. That's concave up and just negative 0.7 and 0. Now we have our other interior interval, which is 0 and 0.7, and that one's concave down. And for the last one that's concave up, we have 0.7 and positive infinity. For those who've stayed this long, I'm just going to show you the other way to write the intervals, because I know sometimes your teacher might be picky on how you do them. This bracket, negative infinity to negative 0.7, you can write this as x is less than infinity. For the interior ones, you say x is in between those numbers, so negative 0.7, so negative 0.7 and 0. So x is in between negative 0.7 and 0. Same logic applies for this one. And then the other one, you probably did it already. This one is x is greater than infinity. Both maximums and minimums happen when the derivative equals 0. In optimization problems, we use simple substitution from early high school math, then apply derivatives to find those max or min values. Good luck studying. Let's find the minimum amount of material required to construct this square-based prism with an open top. Volume is equal to x squared times h, and the total volume is 1,000 centimeters cubed. So 1,000 centimeters cubed is equal to x squared times h. Now let's set up our second formula. Our second formula is area, and the area is just the area of the base plus the area of each side. Remember, the top is open. So the area of the base is just x times x, which is x squared, plus each side. So there's 4 sides, and each side is just x times h. Now we need a in terms of only x because we're about to take its derivative. Let's use formula 1 and substitute it into formula 2. So solving for h in formula 1, we get h is equal to 1,000 over x squared. Step 3 is to obviously just substitute h into a. Let's simplify. So we get x squared plus 4 times 1,000, so 4,000, and then one of those x's cancel. So we get 4,000 over x. Whenever we're dealing with a minimum and maximum, we're always interested in f prime, or the derivative of the function. So we must take the derivative. And then after we take the derivative, we need to check what's going on at f prime is equal to 0. So step 4, let's take the derivative of a. So a prime of x is equal to 2x plus 4,000, and then we're going to raise the x up to the numerator, and that makes the exponent negative. So now it's 4,000 x to the negative 1. Now we can use the power rule. So we get 2x minus 4,000, and then now it's x to the negative 2 because negative 1 minus 1 is negative 2. So this is a prime. Now let's move on and make a prime equal to 0. Okay, so I've made a prime equal to 0 here, and what we need to do is solve for x. So I'm going to multiply both sides by x squared to get it out of the denominator. And we get 0 is equal to 2x cubed minus 4,000. And solving for x and taking the cubed root, x is equal to the cubed root of 2,000. And the cubed root of 2,000 is equal to 12.6. And let's remember that this is in centimeters. So let's sub x back into this formula to get height. So we have v is 1,000, and then x is 12.6, and in this case we're dealing with x squared, and then we have h. So solving for h, we have 1,000 over 12.6 squared, and this comes out to be approximately 6.3 centimeters. You can get full marks on these type of decay problems, and all it takes is 5 minutes to learn the formula and how to use it. So the charge of a battery after t hours is given as p. P is just this exponential function for decay. The question says, what is the half-life of the battery? To figure out the half-life, you need to understand the formula for decay. So P is equal to P0 e to the negative RT. To find the half-life, all we need to do is replace P with 1/2 of P0 and then solve for T. So in our question, what is P0? P0 is 100. So let's replace P with 1/2 of 100, which is 50. So 50 is equal to 100 e to the negative 0.08 t. Step 2 is to just solve for t. So let's divide out 100. So we get 0.5 on the left side. On the right side, we're left with e to the negative 0.08 t. Now we can take the ln of both sides and get rid of this e term and bring that negative 0.08 t term down from the exponent. So ln of 0.5 on the left is equal to ln e to the negative 0.8t on the right. Ln of 0.5 stays the same on the left side here. And then this cancels, and we bring down this negative 0.08t. Now we can just directly solve for t with easy algebra. So t is equal to ln of 0.5 divided by negative 0.08, which is equal to 8.66, and this is 8.66 hours. Okay, moving on to questions 2 and 3. We have find the charge remaining after 5 hours for question 2. That's super easy. All we do is take P here, and P gives us the charge, so we just plug in 5 for T, and we get 67%. So the charge after 5 hours is 67%. Very easy. The third question is a little different. So at what rate is the change decreasing by after 5 hours? Notice the difference here. We have find the charge remaining after 5 hours. So it's referring to the initial formula we're given. This one says at what rate is the change decreasing? When we talk about rates and need to find at what rate something is decreasing, we're referring to the derivative. So P prime is equal to the derivative of 100 e to the negative 0.08t. So to take this derivative, we just take the derivative of e to the x and do the chain rule and account for this inner function, negative 0.08t. So the derivative of e to the x is just e to the x, so we write that down as the exact same thing. Now we account for the inner function. This one right here, what's the derivative of negative 0.08t? Well, that's just negative 0.08. So this derivative that we got from P describes the rate of change, but we need to find it after 5 hours. So P prime, we're going to plug in 5. We get 100 e to the negative 0.08, place t with 5, and we have times negative 0.08. So from the last question, we already found out that this term right here is equal to 67%. So we get 67% times negative 0.08. So our final answer for P prime at 5 hours is equal to negative 5.36. Now, what does that mean? That's negative 5.36% per hour. Remember, this is a rate. We're not just getting the percent here. We're asked what rate is the change decreasing after 5 hours? And since we took the derivative, we now have a rate, and that rate is percentage per hour. So the final answer is negative 5.36% per hour. This is the only video on limits you'll ever need to watch for grade 12 calculus. Trust me. We're going to go over 3 example problems and solve them step by step. Without further ado, let's get started. So this is case 1 of 3. You're mainly going to see 3 cases, and this is probably the most common one. A limit with polynomials in the numerator and polynomials in the denominator. As soon as you see polynomials in any limit, and you're in grade 12 and you're writing a calculus exam, the first thing that should come to your brain is factor. To solve this limit, we're going to factor the numerator and the denominator. So we have x squared minus 6x plus 9. What are 2 numbers that add to negative 6 but multiply to positive 9? So if we're multiplying to a positive but adding to a negative, we're going to have 2 negative numbers, right? So x minus 3 and x minus 3. Negative 3 plus a negative 3, that's negative 6. Negative 3 times negative 3, that's a negative 9. So that's our numerator fully factored. X minus 3 and x minus 3. Okay, so now let's factor the denominator and move along with the problem. So this is a sum and difference of cubes problem. X squared minus 9, we're going to get an x minus 3, and then the positive case, x plus 3. Just like that. Super simple. And then we're going to add that to our denominator in our problem here, x minus 3, then x plus 3. Okay, now it's time to move on, so I'm going to erase all this factoring work we did. Okay, so I've pulled down the factored form. Can we compute the limit yet? No, because the next step after factoring is always to cancel. Step 1 is to ID the limit, and we identified that limit as a polynomial limit. Whatever you want to call it, a limit with polynomials. What is the method when we have polynomials? It's to factor. So the second step is to apply the method. The third step is always to cancel. You cannot compute before canceling in these problems. After we cancel, then, and only then, we can compute the limit. Okay, so let's cancel. So we have a -3 in the denominator and a 2 -3's there in the numerator. So we can cancel 1 out with 1 in the numerator. And that leaves us with x minus 3 in the numerator and x plus 3 in the denominator. Now we can compute this limit. Here we're taking the limit as x approaches 3. All you have to do is replace the x values with 3. So 3 minus 3 divided by 3 plus 3. This gives us 0 in the numerator and 6 in the denominator. So that's our answer, 0. So what you would say is, as the limit of x squared minus 6x plus 9 divided by x squared minus 9 approaches 3, it equals to 0. And that's how you would say that. So remember the steps, and you can solve any of these problems. Okay, so on to the next example. This one looks harder, but I'm telling you, it's way, way easier than the last one. You don't have to factor. This takes 2 seconds, and it's just a bunch of algebra. This type of limit is what I like to call the conjugate limit, or the multiply by the conjugate limit. And the conjugate is best explained through this definition, I think. So if we have the square root of f of x minus a, the conjugate of that would be the square root of f of x, nothing changes, plus a. And the reverse is also true. So let's apply this logic to the problem. To defeat these limits, all you have to do is multiply the numerator and the denominator by the conjugate of the term with the square root in it. So the term with the square root in it is our numerator, and always, 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 what's under that square root stays the exact same. The only thing that changes is the sign of the constant term. So minus 3, the conjugate would be plus 3. And we do the same thing to the denominator. 9 minus x plus 3. Now it's just algebra. Okay, so let's do the numerator first. We have this 9 minus x term multiplied by this 9 minus x term. That negates the square root and just leaves us with 9 minus x. And then we have -3 multiplied by +3. And that's -9. And then the denominator is just x times that whole expression. So x times 9 minus x plus 3. Don't forget your brackets. Okay, so first things first, after we do our method, and our method was the conjugate method, right? What do? We cancel. Okay, so let's cancel. 9 minus 9, that's 0. So these 9s are going to cancel out. And we're left with -x in the numerator. In the denominator, we have x times this whole expression. Do you notice something? Should we multiply that x into the bracket? No, because we can actually cancel it with the numerator. So x canceled with -x. That leaves us with -1 in the numerator, and then that whole expression on the bottom. So 9 minus x plus 3. So now we have finished canceling and we can compute the limit. So the limit of -1 divided by the square root of 9 minus x plus 3 as x approaches 0 computes as -1 divided by the square root of 9 minus 0. So square root of 9 plus 3. This is equal to -1. Square root of 9 is 3. So we have 3 plus 3 in the numerator, or the denominator, which is 6. So the limit as x approaches 0 is just negative 1 over 6. Pretty easy, guys, right? So we apply the method. In this case, the method is the conjugate method. We multiply everything in, numerator and denominator. We cancel. We cancel again, and then we just compute the limit. Very easy. So the next one is probably the hardest example, but once you do it a few times, you'll be fine. Okay, I know what you're thinking already. Oh my God, there's two expressions. So annoying. And I agree. But you know what's not annoying? Finding a common denominator. I think it's super easy. And just doing this a few times will save you tons of marks on your test. Trust me, this is the only other case you'll see. You'll have factoring, you have the conjugate method, and you'll need to find common denominator. So this gets a little bit tricky because sometimes in these problems, you need to actually factor first before you find a common denominator. And in this case, you do. So our first expression, 1 over x plus 2, is fully factored. It's fine. We just leave it alone. But our second expression, 5 over x squared minus x minus 6, is not fully factored. So we need to find two numbers that add to negative 1 and multiply to negative 6. So negative 3 plus 2 is negative 1, and negative 3 times 2, or 2 times negative 3, is 6. So we have x plus 2 and x minus 3. Fairly easy. And now we can find a common denominator. So what are we missing between these two expressions? So x plus 2 and x minus 3 has it all. But x plus 2 is missing something. It's missing that x minus 3. So what do we do? Well, now we have to fill the need. We have to multiply that expression by x minus 3. But not just the denominator, the numerator too. Whatever we do to the bottom, we must do to the top. So first, let's write the common denominator. So x plus 2 times x minus 3. Our first expression there is missing x minus 3, so let's fill the need. Multiply x minus 3 to that 1 in the numerator. So 1 times x minus 3 is just x minus 3. And then our other expression already has this common denominator that we selected. So it's not missing anything, so we just leave it alone. So add the 5. Okay, so we've pretty much done everything we need to do in the first two steps. Identified the problem, applied the method. Now we can cancel. So let's cancel. What can we cancel in the numerator? We can just simplify this. So 5 plus negative 3 is just positive 2. So let's just change that to positive 2. So we have x plus 2 and x plus 2, and we're going to cancel those out. And then we're left with the limit as x approaches negative 2 of this, of 1 in the numerator, and then x minus 3 in the denominator. Let's clean this up. So the numerator doesn't change. There's nothing there. There's an x in the denominator, so let's put in negative 2 there, minus 3, and we get 1. Negative 2 minus 3 is minus 5. So the limit of 1 over x plus 2 plus 5 over x squared minus x minus 6 as it approaches negative 2 computes to 1 over negative 5. So we identified the problem up here. And we identified this as a common denominator problem. And what do we know about these problems? Sometimes you need to factor first. And in this case, we did. So we applied the method. 3, we canceled. And 4, we computed the limit. That's it. I'm about to solve a problem that's guaranteed to be on your calculus exam. This exact question shows up every single year, and most students still get it wrong. But I'm solving it in just 10 minutes and showing you how to get full marks. Let's get started. S is displacement. And when we take the derivative of s, it becomes s prime, otherwise known as velocity. So s prime is equal to velocity. When we take the derivative of the derivative, or we take the derivative again, we get s double prime. And what's s double prime? That's acceleration. So essentially, if you know how to take derivatives, you should be fine. You start off with displacement, you take its derivative, you get velocity. Then if you take the derivative of that function, you get acceleration. So if I asked you to get velocity and acceleration from s of t up here, all you would do is take the derivative of s of t and then take the derivative of that result. Really easy. Just keep taking derivatives. So let's put this in the corner and solve the problem. So A says determine the initial velocity. Okay, well, we need velocity. Velocity is the derivative of s of t, or s prime. Let's take the derivative of this. So 3t squared minus 18t plus 15. And that 4 becomes 0. So that's velocity. So this question says determine the initial velocity. The initial velocity occurs at the start of the race. When do you start timing a race? At 0 seconds. We're not going to start timing a race 2 seconds in, right? We're going to start at the initial point of velocity, which is at t equals 0. So if vi, or initial velocity, occurs at t equals 0, all we have to do is plug in 0 into our velocity equation, right? So v is 0 is equal to 3 times 0 minus 18 times 0 plus 15, which gives us 15 meters per second. So the initial velocity of the object is just 15 meters per second. Super easy. If you ever see initial velocity, that just means the start of the race, otherwise known as when time is equal to 0 seconds. Okay, B. B says at what time is the object at rest? Or what times? So there could be more than one time the object is not moving. At rest just means not moving. Not moving refers to velocity, right? It refers to speed. What is your speed when you're not moving? Your speed when you're not moving is 0 meters per second. And in this case, we're looking for at what time. So time is our unknown, and we're given this hint here. V is equal to 0 meters per second. That's the initial value. So all we have to do is simply apply that to the velocity equation. So this is v of t. We want to know at what time is the object not moving. The object's not moving when v of t equals to 0. So 0 is equal to 3t squared minus 18t plus 15. Now it's just a factoring problem. So I'm going to pull out the 3, common factor that 3 out, get 3t squared minus 18 divided by 3 is 6t there, and then plus 15 divided by 3 is 5. So now it's just a easy trinomial. 0 is equal to 3 t squared minus 6t plus 15. What are two numbers that add to negative 6 but multiply to, oh, that's my mistake. What are two numbers that add to negative 6 but multiply to positive 5? Well, if we're trying to add to a negative number but multiply those same numbers to get a positive, I think they both need to be negative. So that's just t minus 1 and t minus 5. So negative 1 times negative 5, that's a positive 5. Negative 1 plus a negative 5. We're just adding a negative to a negative, so that's negative 6. All right, that's great and all. We discovered that object at rest means v equals 0. And we factored this. But how do we actually get the times? Super simple. Now we just take the roots. So v is equal to 0, or the object is at rest, at t is equal to 1 second, and at t is equal to 5 seconds. That's it. So just a quick summary. Initial velocity means time is equal to 0. At rest means v is equal to 0. So write that down. All right. This one most students get wrong. Okay, but once you do it a few times, you should never get it wrong again. It's actually super simple. It just involves some stuff that's not familiar to most grade 12 students. So, to determine the intervals over which acceleration is positive, we need to do a few things. We need to determine acceleration. We need to determine when it's positive, and we need to determine the interval over which it's positive. Okay, so let's do the thing we know how to do and take the derivative. Earlier, we were given s prime of t, or we found s prime of t, which is the velocity, and we found that to be 3t squared minus 18t plus 15. We found that to be this function. Now we need the acceleration, so let's simply take the derivative again. So s double prime of t, which is equal to the acceleration, is just the derivative of the velocity function. So 2 times 3 is 6t right there, and then minus 18, and then that 15 is a constant, so it's 0. Okay, so we found the acceleration. Now it's asking us, when is the acceleration positive? In other words, when is acceleration greater than 0 meters per second squared? And that's just the units for acceleration, meters per second squared. So when is acceleration greater than 0 meters per second squared? How do we write that mathematically? That's when is a greater than 0. Okay, so what is a? A is 6t minus 18. So when is 6t minus 18 greater than 0? Now it's just an inequality. How do we find the interval at which it's positive or greater than 0? We simply solve for the input. The input is t. So let's solve for t. So 6t is greater than positive 18. T is greater than 18 over 6, meaning t is greater than 3. What does that mean? That means that acceleration is positive when time is greater than 3 seconds. That's all we got to do. So first, find the acceleration, determine when it's positive, so determine when a is greater than 0, and then just solve for t, and t gives you the interval. The equation of the tangent line is just like any line. It's really just y equals mx plus b. So all we need is a slope and some offset. The slope of the tangent line is just equal to f prime of x. So step 1 is to find the derivative. Here's a really easy way to remember the quotient rule. So first things first, let's just put the denominator in the denominator and square it so we don't forget. So the first portion of the numerator is the derivative of the first times the second. So the derivative of x squared, which is 2x, times the second, which is e to the x minus 1. The other portion is the first times the derivative of the second. So what's the derivative of e to the x minus 1? Well, it's just e to the x minus 1. So we have a general slope equation for the tangent line, but we're required to find the slope at x is equal to 1. So to do this, we just plug 1 into the derivative. So 2 times 1 times e to the 1 minus 1. 1 minus 1 is 0. And then we have 1 squared. And all of these e to the x minus 1s just turn into e to the 0s. Anything raised to the power of 0 is 1. So what we get here is 2 minus 1 over 1, which is equal to 1 over 1, which is equal to 1. Now that we have the slope, we can move on to the easy part and finish this equation. Step 2 is to find f of 1, and this gives us our y value for the equation. So f of 1 is just 1 squared over e to the x minus 1, which we know this is e to the 0 here. So this is just 1 over 1 again, giving us 1. At this point, we have found everything we need for the equation of the tangent line. Now we just have to put it together. I'm going to show you how to write the equation of the tangent line in two different forms. So point slope form looks something like this. All we have to do is fill in the blanks here. So y minus y1, which is 1, is equal to the slope, which is 1, times x minus x1, which is x minus 1. And this is point slope form. The second form is just regular old y equals mx plus b. So to get to y equals mx plus b, all we need to do is take the point slope form and solve for y, while also distributing this 1 into the bracket. So y is equal to 1 times x minus 1 plus 1, because I transposed this 1 here. And now let's distribute that 1 into the bracket. We get x minus 1 plus 1. These cancel. That's 0. Minus 1 plus 1 is 0. And now we have our final answer. Y is equal to x. Let's solve some tricky derivatives that I found on a calculus exam. And by the way, thanks for even making it to this portion of the video. So if we bring that e to the 2x up to the numerator, this problem becomes way easier. So when we bring it up, we just have to make the exponent negative. So e to the negative 2x is now what we have, and then we have it multiplied by this term in the numerator. Already, this product rule derivative is much easier than the quotient rule, but we can make it even easier than that by just multiplying e into the bracket. And in the top right-hand corner here, I've outlined this exponential rule, and this just says when you multiply e by e, be sure to add the exponents. But let's multiply e into the bracket. We get e to the negative 2x, and then we're adding the exponents, so e to the negative 2x plus x, and then we have e to the negative 2x plus a negative x, or we can just say minus x. Now we can simplify. We have e to the negative 2x plus x, that's just e to the negative x, minus e to the negative 2x minus x, so that's e to the negative 3x. And look at that. We've manipulated this with algebra into becoming a super easy derivative. So let's take the derivative now. We just get negative e to the negative x, and then minus a negative 3 times e to the negative 3x. Simplifying this even more, we have negative e to the negative x, minus and minus, so we get a plus 3e to the negative 3x. Now we just did the derivative in 2 lines, and honestly you could have done it in 1 line because we manipulated it algebraically before even starting the question. So whenever you see something like this, be sure to at least attempt at doing that, because it can save you a lot of time and stupid mistakes on your exam. So the derivative of a to the x is a to the x ln of a. So let's do that. We have a to the x, and then ln of a. But we're not done, because we have an inner function, tan of x. The derivative of tan x is just secant squared x. So here's another trick. When you have a term under a square root, that's equal to raising that term to the power of 2. When we take its derivative, we need to do the power rule plus some chain rule. So f prime of x is just equal to 1 over 2 times the entire thing here. But be sure to subtract the exponent by 1. So the exponent is 1 over 2, which is 0.5, minus 1 is negative 0.5, so that's negative 1 over 2. And then now let's take into account the inner function. The inner function is just the derivative of x squared minus 2x plus 1. So that's just 2x minus 2, and then that 1 just is gone because the derivative of constant is 0. So to simplify this further, we can bring this whole term down into the denominator and say, okay, this is now the square root of x squared minus 2x plus 1. Remember, when we bring this down, we change the sign, right? So it's no longer negative 1 over 2. It's to the power of positive 1 over 2, which is just the square root. And in the numerator, we have 2x minus 1. No, 2x minus 2. Divide everything by 2, we get x minus 1 divided by everything under the square root. And that's our final answer. We have a trigonometric function, and within that trigonometric function, we have another function, 2 to the power of x. So first we have to take care of the whole thing, which is called the outer, and just take the derivative of tan 2 to the power of x. So anytime you have this, you just use the derivative of tan, which is secant squared x. And then within that bracket, just replace it with whatever's in the bracket in the original function. In this case, that's 2 to the power of x. Now we have to account for that 2 to the power of x because it's the inner function, and we do that by multiplying it to the outer. So the derivative of the inner is just 2 to the x ln of 2. And that's the final answer. So when you have the product rule, I like to remember it as the derivative of the first times the second plus the first times the derivative of the second. So what's the derivative of the first? The derivative of x is 1 times the second plus the first, which is x, times the derivative of the second, which is 2 to the power of x ln of 2. And then we can simplify this by pulling a 2 to the power of x out, and that leaves us with 1 plus x ln of 2. Okay, so here's an example on how to easily remember the quotient rule without needing the formula or forgetting things. So the first thing I do is just write the denominator down and square it, because it's easy to forget. It's easy to forget to actually square that denominator, which will cost you marks on your exam. Next, I follow this pattern. I take the derivative of the first and multiply it by the second. Then I take the first and multiply it by the derivative of the second. And I think that's way easier than trying to remember that giant formula. So in summary, square the denominator, then deal with the numerator, and that's the derivative of the first times the second minus the first times the derivative of the second. In this video, I'm solving 3 must-know derivative problems using first principles, the kind that always show up on tests. I'll show you the only formula you need, how to set up each case, and how to use limits to get full marks. So let's start out by writing the formula and doing f of x plus h. So the limit as h approaches 0, I'm just going to put h in the denominator because it's not going to change. All right, how do we do this f of x plus h term? So what we do is we deal with the variable terms and then add the constant at the end. So take the coefficient of the first term here, x squared, and put it down. So the coefficient of x squared is just 1. That's actually 1x squared, right? Then you just write the bracket, so x plus h, and raise it to the power of the variable you're looking at. Okay, so what's the power of this variable? Well, it's x squared, so it's the power of 2. So we're going to raise the bracket to the power of 2. That's it. That's all we do. And then we move on to the next variable. So what's the first step? Coefficient of the variable. Coefficient of negative x is negative 1. Then we just place the bracket and raise it to the power of the variable. What's the power of negative x? It's just 1, right? So we keep it like this. And then add the rest, right? Plus 1. So that's the f of x plus h term. Finished. Next, we're just going to do the negative f of x term, which is pretty simple. It's just negative, and then whatever your function is. Okay, so after you finish putting everything in the formula, all we need to do is some algebra and then factor. So let's start with the first term here, 1 times x plus h squared. So what we're going to do is FOIL this term. A quick shortcut for FOIL is square the first, square the last, multiply together and double. So multiply together x times h and double. So 2x times h. So that's your result, x squared plus 2xh plus h squared. So square the first, square the last, multiply together and double. Next, we're just going to distribute the negative into the bracket here. So negative x minus h, then plus 1. Then we're going to distribute this negative into the last bracket. So basically just reverse all the terms. So negative x squared now, and there's a positive x, and then a negative 1. Let's start with x squared. Is there another x squared term? Yep. And it's negative x squared, so we have a positive x squared and a negative x squared, so they're going to cancel out. Next, we have 2 times x plus h. Is there another term like that? No. So let's just write it in. Now we have h squared. Is there another term like to h squared? Nope. So add h squared. Now we have negative x. Okay. Well, negative x, we can cancel that with positive x. Now we have negative h. Negative h also goes in here. And then we have plus 1 and minus 1. So cancel out these ones. Okay, so we're basically done now. All we need to do is take the limit. And what do we need to do before we take the limit? Identify the limit, so what type of limit it is, apply the method we know, cancel, then compute. Okay, so what type of limit is this? I don't see a square root, so we don't use a conjugate. We don't need to do a common denominator, so it's obviously a factoring one, right? It's a polynomial, and we have to factor. This is super easy. All we're going to do is factor out an h. As you can see, there's an h in every term, right? So we're just going to factor that out. Okay, so h out. Now we're left with 2x because we took the h away, plus 1h because we took 1h away, and then we take an h away from negative h. That leaves us with negative 1. Okay, so if you multiply that h back into the bracket, you should get the original term. The next step is just to cancel. So obviously, this denominator is going to cancel with this h in the numerator, and we're just going to be left with 2x plus h minus 1. Okay, so now applying the limit. This one's really easy. I'm just going to make a big red box down here. Apply that limit in. That h is going to go to 0, and there's no other h in here. So the limit as h approaches 0 of 2x plus h minus 1 is just 2x minus 1, and that is f prime. So we just differentiated that function using first principles. So our function is 2 over 2x plus 1. We're only worried about the variable for f of x plus h. So let's just put the 2 in the numerator and move on. Okay, so the variable is 2x. First things first, coefficient. Then you put x plus h in place, and then raise it to the power of the variable. So the power of 2x is just 1, and then add the rest. Just like that. Now we subtract f of x. F of x doesn't change, it's just f of x as given in the question. Just like this. So the common denominator is these two guys right here multiplied together. So let's just do that right now. I'm going to multiply that 2 into the bracket as well. So 2x plus 2h plus 1. All I did was multiply this 2 into the bracket. Okay. So to make a common denominator, we're just going to multiply the two denominators together. So the first one there, and then the denominator of f of x, or minus f of x, is here. That's 2x plus 1, and we just have them multiplied together. What we have to do here is change the numerator and give it what it doesn't have. So we do 2 times what it doesn't have. What doesn't it have? 2x plus 1. Easy. Now, we have negative 2 on the other side. Negative 2 is missing the whole other term, so we do the exact same thing, but we use the other term. So 2 times 2x plus 2h plus 1. What it's missing. Amazing. Let's distribute those 2's in. So 2 times 2x, 4x. 2 times 1, positive 2, minus negative 2 times 2x, that's negative 4x, and then minus 4h minus 2. So let's cancel. This 4x is going to cancel with negative 4x. The 2 is going to cancel with negative 2. And we're just left with negative 4h. Let's put that in the middle. Cancel first, then compute. So let's cancel. We have negative 4h and then times a 1 over h. So these h's are getting canceled. Let's just get rid of them. Multiply that 1 in, really it doesn't matter. We can just erase that times 1, right? Now we have -4 over all this, and let's compute the limit. 2x, and then that h term is just 0. It's 2 times 0, 2x plus 1, and then there's no h term in the other term, so 2x plus 1. And that is our final answer. You can write this as 2x plus 1 squared, or you can just keep it like this. Okay, so to create the f of x plus h term for this case, we put everything under the square root, and we just do 4 minus x plus h, right? The coefficient is -1, and the power is also 1, right? So that's correct, minus f of x. F of x is at the top there, divided by h. Okay, so we did it. Now we're solving a limit. So how do we solve limits with square roots in the numerator? Easy. They're conjugate limits. So you multiply the top and bottom by the conjugate. What's the conjugate? The conjugate is the exact same thing as the numerator, but we switch the sign between the two terms. So instead of the square root of 4 minus x plus h minus the square root of 4 minus x, it's plus the square root of 4 minus x. So you just simply switch the signs. Okay, and we do the same thing down here. 4 minus x plus h plus instead of minus, right? That's it. Now we're just going to multiply those in. Then we're going to do the numerator. Basically, we just get rid of the square roots. So 4 minus plus h minus 4 minus x, brackets. Let's distribute those negatives in. Okay, so 4 minus x minus h minus 4 plus x. Now we're on to the really easy part, cancel and compute the limit. So let's cancel first. This 4 cancels with this 4, or this -4. This negative x cancels with that positive x. This negative h cancels with this positive h down here. But we're left with a -1, right? Because we still have that negative symbol there. So the numerator is -1, not +1. And the denominator is just the square root of 4 minus x plus h plus square root of 4 minus x. Let's compute the limit. So we're going to replace all the h's with 0. The root of, well, if that h becomes 0, it's just 4 minus x now, plus square root 4 minus x. And that's the final answer, but you can further simplify by just representing the denominator as 2 times the square root of 4 minus x instead of having them separated. So that's it. That's the third variation of this. It's basically just limits. You just have to know how to do the f of x plus h term. So let's find the average rate of change from x is equal to 2 to x is equal to 4. So this is a very easy problem. The first step is just to calculate your y values by plugging in your x values. So let's do f of 2 first. F of 2 is 2 over 2 minus 1. 2 minus 1 is 1, which is 2 over 1, which is equal to 2. So f of 2 is equal to 2. So the y value corresponding with x is equal to 2 is also 2. And f of 4 is just 2 over 4 minus 1, which is 2 over 3. So the y value corresponding with x is equal to 4 is 2 over 3. So those are the steps you need to complete to solve the average rate of change. To actually calculate it, we just simply calculate the slope as you would do in grade 9. So m is equal to the change in y values, or the rise, over the change in x values, or the run, which is y2 minus y1 divided by x2 minus x1. What's y2? That's 2 over 3. What's y1? We just calculate that as 2. And x2 minus x1, that's just 4 minus 2. And plugging that into your calculator, you should get negative 0.666666667, or if you do it in fraction, that's negative 2 over 3. All right, so that's the average rate of change, super easy. Just y2 minus y1 over x2 minus x1. Next, we're going to calculate or estimate the instantaneous rate of change at x is equal to negative 1 without even taking the derivative. So this is just as easy as the first question, but a little more annoying. So the first step of this problem is to calculate the inputs in the formula. Here is our formula, f of x plus 0.01. Then we have an f of x minus 0.01. So let's do f of x plus 0.1 first. So what is x? X is negative 1. Negative 1 plus 0.01. And then we have f of negative 1 plus, or nope, we have f of negative 1 minus 0.01. Okay, so this ends up being f of negative 0.99. Negative 1 plus is 0.01. That's negative 0.99. And f of negative 1.01. Okay, so now we just plug those into our original function. It's the same function as last time. These are our inputs. Let's just plug them in. So 2 over negative 0.99 minus 1, and 2 over negative 1.01 minus 1. So if you put that into your calculator and compute it, you should get negative 1.005 for the first one, and then negative 0.995 for the second one. What's next? Well, we have all the values for our formula. Now let's calculate the instantaneous rate of change with the actual formula. So the instantaneous rate of change is equal to f of x plus 0.01, which we calculated as negative 1.005, minus f of x minus 0.01, which is this, so minus a negative 0.995, and all divided by 0.02. Simply plug that into your calculator and you'll get negative 0.5. Thank you so much for watching. This video series took forever to make, and I really appreciate the fact that you made it to this point in this video. Good luck on your exam.